Okay, so I just want to do the same thing with these different types of scenarios, different types of quadratic equations. 2x squared plus x minus 5 equals 0. Let's see what we can do with factoring that. Okay, 2x squared plus x minus 5 equals 0. And when I try the same thing, I know it has to be 2x and x, and this time the only choice is 5 and 1. It's the only thing that multiplies to 5. I try the 1 and 5 this way. My outer is 10, my inner is 1. There's no way 10 and 1 add or subtract to get 1. I put my 5 here and my 1 there. Now my outer product is 2x, my inner one's 5x. And again, that's not going to give me 1. So the issue with factoring, obviously, is it doesn't always work. I would have realized that had I found the discriminant. Okay, the discriminant, remember, is b squared minus 4ac, what's under the quadratic formula, b squared 1 minus 4 times 2 times negative 5, okay, b squared minus 4ac is 1 plus 40 or 41. And 41 is not a perfect square. So when I try to, once it's under this quadratic formula, I know I'm going to be trying to take the square root of it, and I can't. So let's see what happens with the quadratic formula. We get the opposite of b, plus or minus the square root of b squared, but we just did this, minus 4 times a times c. We know that's going to be 41 all over 2a. So I have negative 1 plus or minus the square root of 41 over 4. So my two answers are negative 1 plus the square root of 41 over 4, or negative 1 minus the square root of 41 over 4. Well, if I want to see where they are on my graph, I kind of would like to have a decimal approximation of what that is. So I'm going to try and figure that out on my calculator. So go ahead on your calculator and type that in. Okay, be careful, guys. Don't just type negative 1 plus the square root of 41 over 4. Okay, because we want the negative 1 to also be divided by 4. And the way I wrote it in my calculator here, or typed it, it's only going to take 4 into the square root of 41. Okay, when I hit enter, I'm going to get the wrong answer. I get 0.6. Okay, when the real answer, let's put it in parentheses, negative 1 plus the square root of 41. Notice how the calculator puts a paren there, so I have to close it. Okay, I'm putting the negative 1 plus the square root of 41 in parentheses, so I'm telling the calculator, okay, do that first. I'll need to end my second parenthesis. This first parenthesis ended the 41, right? And then I'm going to divide by that whole thing by 4. Okay, that's the actual answer. And I get 1.35-ish. Okay, just so I have an idea of about where that should be, so that when I graph it, I know that was about 1.35. Okay, and then obviously the other one, here's a little hint. If I do, see right here, it says entry. If I do second entry, it brings what I typed in last right there, so I can backspace and just hit minus. Negative 1 minus the square root of 41 over 4, and that answer is negative 1.85. Okay, about negative 1.85. All right, so my two answers, the exact answers, are negative 1 plus square root of 41 over 4, negative 1 minus square root of 41 over 4. My approximate answers are about 1.35 and negative 1.85. If I graph it on my graphing calculator, not if I graph the y equals 2x squared plus x minus 5 is what I would want to graph. Y equals 2x squared plus x minus 5. Let's see what that graph looks like. If I graph it, it looks like it's going through about 1.5, but I know from my work that it's actually 1.35. And this looks like it's going through -2, doesn't it? But it's not. It's going through -1.85. All right. If you want to know the exact zeros, you can calculate that by hitting second, calculate, which is right here above trace. And it says, what do you want to calculate? Well, I would like to calculate the zeros, where this function equals 0. Okay, and it says, ask me to go to the left of my first 0. So I want to go to the left of this one. There we go. And then it asked me to go to what my right bound of my 0 is. Well, let me trace to the right bound. There, that's good enough. As long as I'm to the left and to the right. Stand up, sit down, fight, fight, fight. I got it. My 0, do I want to guess? No. Can you please just tell me? Gosh, I don't get that part. The 0 is -1.85. Well, that's what we got. Y is -1.850781. Okay, fine. So we go back, that's what we got, right? -1.850781, but it stops there. Okay, anyway. Where was my graph again? I do want to see that. Okay, so I would just kind of sketch that here just for the completeness. I sort of was hoping you'd have a picture of it so you understand. This has 2. It's crossing at, what was it, -1.85, 1.35. I don't really care where the vertex is right now. I'm just showing you this is 1 plus the square root of 41 over 4. And this is 1 minus the square root of 41 over 4. Those were negatives, weren't they? Yes. Okay. So hopefully you have your complete graphic organizer. The discriminant was 41, which since that was not a perfect square, I should have realized, hey, this isn't going to factor. Excuse me. All right. Let's try this next one. I think I'm going to find the discriminant because I don't feel like wasting time trying to factor this if it's not going to work. The discriminant is b squared minus 4ac. So that's 144 minus 4 times 9 times 4. That's 144 minus 144. Oh, the discriminant 0, so this should factor. In fact, it should be a perfect square. I know that my 2 terms have to multiply to 9, and now that I know my discriminant is 0, I know I should have the same exact terms. So instead of 9x and 1x, I'm going to try 3x and 3x. 4, I'm going to try 2 and 2. Since the middle term is negative, I know that they're both negative. Let's see, that's 9x squared minus 6x minus 6x. That gives me my minus 12x plus 4. Great. So I have 3x minus 2 equals 0, or 3x minus 2 equals 0. Is there an echo? We don't have to write that same thing twice. 3x equals 2, x equals 2/3. This time there is only one answer. Okay, there's not always 2 answers to a quadratic equation. Sometimes there's just one. Okay, graphically, what's that mean? That means that well, let's see what it means. Let's graph it. Y equals 9x squared. Go ahead and do it on your graphing calculator. Y equals 9x squared. What was it? Minus 12x. To move myself. Minus 12x plus 4, I think. When I graph that, I get a parabola that just hits once. Right at 2/3. It looks a little bit below 1, right? We know that's 2/3 because we solved it algebraically. We don't have to rely just on the graphing technology. We have our brains. So we are going to go to 2/3. I just want you to sketch it. Okay, sorry, that should be nice and smooth. One answer, 2/3. If you would have done it by the quadratic formula, that's obviously fine with me. By the quadratic formula, we're going to have opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's 12 plus or minus the square root of 144 minus 144 all over 18. So 12 plus 0 is 12. 12 minus 0 is 12. I don't get two answers. I'm adding and subtracting 0. I get 12/18, which if I divide that by 6, I get 2/3. Divide top and bottom by 6. Okay? Quadratic formula gave me 2/3. Factoring gave me 2/3. When I graphed it, I could tell it was 2/3. And the discriminant told me it could be factored because I got a perfect square of 0. It also told me that, hey, you're only going to get one answer. You're going to be adding and subtracting 0. All right, and the last type, x squared minus 2x plus 4. Again, I want to see if this can factor or not. I'm not going to waste my time if it can't. B squared, okay, negative 2 squared is 4 minus 4ac. So 4 times 1 times 4. That's 4 minus 16. I get a negative 12. I'm going to be taking the square root of a negative here, gang. I'm not going to waste my time factoring. I can tell that's not going to work. Okay, I just write can't factor. So luckily I have my other way. I have the quadratic formula. So I am going to take the opposite of b plus or minus the square root of b squared minus 4ac, which I just found was negative 12, all over 2a. So that's 2 plus or minus. We learned this last chapter in P7. I'm going to bring the I out. I also know that, well, let's write it out. This is negative 1 times 4 times 3, right? I can take the square root of negative 1, it's I. I can take the square root of 4, it's 2. I'm going to write 2i. I don't like to write I2. It's not proper. 2i squared roots of 3 all over 2. Well, since the 2 can go into both of these, I can take 2 into both of these. The final answer is 1 plus or minus I squared roots of 3. They're imaginary, so I'm certainly not going to graph them. What does this look like graphed? Well, let's do it. X squared, I'm going to type in y equals x squared minus 2x. I kind of forget. Oh, yeah. Y equals x squared minus 2x plus 4. Y equals x squared minus 2x plus 4. When I graph it, see where this is crossing the x-axis. Oh, nowhere. It doesn't cross the x-axis, thus imaginary roots. Okay, when you don't get any answers to a quadratic set equal to 0, what that means is parabola never touches. I know that's not quite right. Parabola never touches the x-axis or crosses it. Okay, so to review, sometimes it factors. We get two answers, a half and negative 4. Let's think about what the discriminant is. It was 81, a perfect square. It's telling me I'm going to get two rational answers. Okay, when I did the quadratic formula, that was fantastic. The quadratic formula showed me the same thing, right? Okay, and when I graphed it, it crossed nicely at negative 4.5. Sometimes it doesn't factor. It doesn't mean there's not two real answers. Here I have two real answers. They're just not rational because I can't take the square root of 41, but they're real. It crossed the x-axis. I have two answers. They're just not rational. They were irrational. They're not imaginary. They're irrational. Here, I just got one answer. It factored. I got 0 for the discriminant, which meant there was only one answer. It was 2/3. What's that look like? Well, it looks like it just touches once.